Hello, I've been using one of these radiolink mini-pix flight controllers for a while now, and I've got to say I really like the performance of the Ardupilot firmware. This one works really well, and I set it up on a flying wing, and then I tried it on my quadcopter, and then I got another one for a friend and we set that up on his octocopter. And just recently I've taken this one and put it onto a second flying wing. And the first time I tried this was a bit of an ordeal for me because I was unfamiliar with the user interface and mission planner and all that stuff. And I made a few videos that were newbie fumbling, was what I put in the title, for one of them at least. And it was a bit of a mess. But I thought what I would do the second time on this second flying wing that I was setting it up on was to take some notes as I went to serve for myself as a future reference, and also I might upload it as a video because I've had a few questions of people asking me to make a bit more of a how-to video, more of like a tutorial instead of just a fumbling idiot trying to do things video. So that's what this is going to be. So this is going to be one of those videos that almost doesn't need to be a video, because what I've done here is these are the notes that I took. It's actually not too much to it, but some points are fairly important, so that's why I took the notes. And you could pretty much just sort of go through this. I'll put a link to this in the description if you just want to download this text file, and if you are savvy enough to get through it, you might find this just to be enough. But anyway, let's go through this, and I will show you occasionally where to go to make these settings and so on, because if you are unfamiliar with everything, it sometimes is a little bit nicer just to see somebody actually doing it, so that it doesn't look so foreign to you when you come to do it. So this video is going to be specifically about setting up a flying wing configuration. I might just take a moment to answer a question that I've had fairly regularly since I uploaded those first few videos, and that is this thing worth it? And the answer to that is definitely yes. It's just such a reasonable price, and it works fairly well. In fact, when I saw that there's only 3 units available, I almost got another one just before making this video. Oh, that's the US warehouse. No problem. Oh, no, they're not. Okay. Yeah, but you get what you pay for, as the saying goes. So now that I've had 2 of them, I've actually had 2 what I perceive to be hardware problems. This thing itself, the flight controller, seems to be fine, but the first one of these I got, basically this buzzer just never worked. I never heard a peep out of it at any point, and I wasn't entirely sure if it was broken or not, but when I got the second one, the buzzer works fine. So obviously the buzzer in my first one was not working. And the second one, as we'll probably see a little bit later, it seems like the sensor for current is not giving me any values. So there could be a problem with this power module. Voltage is working, fortunately. That's a little bit more important. But yeah, there could be a problem with the voltage or the current sensing bits on here. I haven't really looked into it too much. But not completely a bed of roses. For this cheap price, I guess you are getting something that was made not quite to such high standards. But on the whole, I think definitely worth it, and yes, I would get another one. And just before we get started, I would also highly recommend that you get hold of a set of these transceiver telemetry radio thingies. These are made to work with Mission Planner right out of the box, and they are hugely beneficial in setting things up, because it means you don't need to have your plane physically connected to the computer with a USB cable. And especially if you have a big plane and you want to do something like compass calibration, or even in my case I found just moving it around the house is kind of a pain in the ass. So it's really nice to be able to just sort of connect to the plane from one end of the house when your laptop is at the other end of the house and so on. So anyway, I'll just sort of assume that you'll have one of these as we go through. Okay, let's get started. The first step is to download the radiolink mission planner, and this radiolink bit is important. You will not be able to use the default or the official mission planner. Radiolink have done something to this version that lets it install onto this particular flight controller. So you go to that web page there, and the link for their mission planner is there. So just download that and install it. I should have mentioned that you'll need a Windows computer to do this, but can't be helped. Anyway, next step is to plug in the USB cable, and you should see something called PX4 flow showing up in the device manager, which will look a little bit like that, and you'll see the COM port here. I've found that usually Mission Planner can figure out which COM port it's on, so you can use the auto setting, but just in case it doesn't, you can look at this to see which COM port you're using. So Mission Planner is here. I've already started that up. What was the next thing to do? So we'd go to Initial Setup, Install Firmware, select Plane, and then follow the instructions. Now I'm not going to do this because otherwise I'll mess up my existing installation, but Initial Setup is there, Install Firmware is there. This is just going to check something on the internet. So you'd select Plane, and then you'd click Yes to install that. Oh, and the options for choosing the COM port are up here in the top right. So I found that I could just leave it as auto, and when you do that it defaults to, well, it disables the baud rate there, so it's just going to figure out what the baud rate is itself, I think. And that worked fine for me to do the firmware installation. I'm not seeing my COM10 in here right now, but I also noticed that there's a little warning mark on this device, so something's a little bit strange with it. But as it happens, that doesn't really matter for me anymore, because as long as you have a set of these to use, this is the last time that you'll ever need to connect the flight controller by USB. So if you do have these radio modules, you're going to plug one of them into your laptop and one of them into the flight controller. And when you plug it into your laptop, you should see something called USB serial port showing up there. And on the flight controller side, you're going to have to do a little bit of soldering, unfortunately, because the type of plugs that are used on these are different to the plugs that are used on this thing. So you'll have to cut one of these cables. There's a 6-wire cable, and solder. Yes, you have to get your soldering iron out. It's a bit of a bummer, isn't it? Fortunately, they give you a spare, or I guess maybe it's made for this kind of purpose, but one of these plugs here, you'll see it has just bare wires on the other end. So you'll have to solder this together to make your own cable. And to get the pins in the right place, you can look at this diagram. So you're going to be plugging it into one of these telemetry things down here. I think either one is fine. And you can see they've labeled them there. And the labels for this radio module are printed on the case there, so you can make sure you get the right wires connected to each other. Anyway, with everything plugged in, you should be able to connect over that telemetry connection now, and I found that it seems to work at 57600 baud, and occasionally I get an error showing up that says something like access denied or permissions required or something like that. And I found that that was fixable by unplugging the telemetry module from the laptop side, that is, and plugging it in again, and I've never had it fail more than once like that. So this time you actually have to select the COM port, I think. Actually, let's try auto and see what happens. But you can see that I have COM 11, so if auto... No. Oh, let me try it. Let's see what happens. Did I click it? Did it find it? Okay, it did. So there we go. COM 11 and 57600. And you'll see it does all this getting parameter stuff like that. So it's successfully connected. And I've found that this is extremely slow. I've never seen this finish in under 3 minutes. I have had people tell me that that is unusual and it should be faster. But for whatever reason, my one takes that long. I don't worry about it too much because it does eventually work. Okay, now for the next set of steps here, this bunch of things there, it doesn't really matter what order you do them in, but some things will be a lot easier when everything's already mounted in the plane. For example, the compasses, yes, there are 2 compasses in this setup, they'll need to be mounted facing the correct direction, and setting the plane level, obviously you need to have the flight controller mounted in the plane to do that, and these pieces here, and these steps here, you need to check the direction of the servos and everything. So that's why at this point here I say mount everything in plane before going ahead. That's just my suggestion. And these ones here actually are a little bit easier to do before you do that, so maybe you could still do these ones by USB. So anyway, first one is to calibrate the accelerometer, so let's have a quick look at that. So we go to the initial setup tab, and all those things that I mentioned there are listed down here, and it's pretty easy if you just follow down through this step by step. So accelerometer calibration. This top one here, this 3-axis calibration, you would click that and then it will show you some instructions here, and there'll be a click to continue button when you have placed the flight controller in each of the orientations that it requests you to do. So I actually find this a bit easier to do before I've put it in the plane, just sitting at the desk where I can easily hold the flight controller. For example, it'll say tip it to the right 90 degrees or something like that. And that's all you do for that. What was the next one? calibrate the radio. Okay, so first we need to connect the radio. So let's just go back to this page for a second and look at the connections. So we've got RC in over there, and that is GNS, supposed to say GND, I think. So that's ground, VCC, and RC is the ones that we're interested in. So this RC is going to be either PPM or S-bus input, and one of the plugs that comes with the kit, I think it's the one that has this, it's a bit hard to see there, but it's this one, and then there's a set of 3 there that will come out. So this set of 3 will go typically into your S-bus output from your receiver. So I should have mentioned at the beginning, you need a receiver that can output either S-bus or PPM. And interesting thing is that in Mission Planner you don't actually need to specify whether you're using PPM or S-bus, it will just figure that out. So on the radio calibration tab then, you should see your sticks moving around. It's a little bit sluggish, but they do move around. So you would click calibrate radio, and then you would move all of your sticks and switches to their maximum extents in each channel. And while you're doing that, you would see a little red line showing at the endpoints of each channel, and then if I remember correctly, the button here will change to done, and when you're finished then you would just click done, and that would be the radio calibrated. Now reverse pitch channel, this is a bit of a strange one. I'm not really sure why this is the case, but let's see what happens when I push my pitch stick forwards or up. So you can see it's gone down like that. Now when I say reverse pitch, I do not mean this. I did not touch this. I don't know where this checkbox comes from, but I found that unchecking it messes things up even further. So what I've done to reverse the pitch is I just reversed it in my radio on my transmitter. Something really weird going on. I don't want to touch it now, but yeah, check that your pitch is going the right way when you're checking your elevons and everything in later steps. Just be aware of that. Alright, so setting flight modes. You'll also need to possibly change this flight mode channel. So you're going to select a switch to be the switch that will change the flight modes. And by default it's channel 8, which I did not want. And this is where we're going to first come into contact with the full parameters list. So remember this here, flight mode channel. Yep. So if we go into flight modes, now this is a little bit unclear what these numbers up here mean, but this current PWM, and then it has a 5, this 5 means that channel 5 is the channel that will be used to select the current flight mode, and the current value of that PWM pulse on that channel is 2003. So if I change my switch there, it'll change to about 1500 or about 1000, and you can see by the highlighted item in green which that would currently be. Let's just see how you can change this if you don't want it to be channel 8. You would go to config tuning section, and there may be other tabs that it shows up in, but I find that the most reliable way to find the parameter every time is just to come to this full parameter list. It's a little bit slow to load as well, but after a few seconds you can type in here. It's an enormous list, that's why. Flight mode, there it is there. Right, so you can just select this cell and then type in whatever channel you want that to be, hit enter, and if you click away somewhere you'll see that this cell is green, meaning it's been changed. Has not been written to the flight controller yet, so you'll need to do write params if you want to send that to the flight controller to finalize it. I actually don't want to do that, so put it back to 5, and I shouldn't need to write parameters, but anyway, this is how you would change one of the parameters, and we'll come back to this page quite often because anywhere you see something like this with this uppercase name, that is referring to one of those parameters in that huge list. And I would highly recommend that you're kind of forced to have a manual flight mode all the time, and then for your first flights you would, in almost every case, set it up to be fly-by-wire A and then auto-tune on the other modes. So you kind of need to have a switch that has 3 modes to do this, obviously. If you have a 2-position switch, I guess you could still do it, but it's just a little bit more convenient to be able to do it all in one flight. So for my case now, if I fiddle with my switch here a bit, we'll see that I had manual there, fly-by-wire A, and on this last position I had return to launch. So to change that to auto-tune, I would select here and then do save modes like that. Like this, and you can double check that the modes are doing what you wanted by looking at this display in the bottom right here. So I've got manual, quite slow to update, takes a couple of seconds, but you can just use this to double check what mode you're currently in, just to check that that switch is working as you expected it to. So at this point, if you're coming from another flight controller system, you might be wondering what fly-by-wire A means. So I'll just point you to this page which shows the long description of it. But to sum it up very briefly, it's auto level mode, or angle mode, maybe you might call it an iNav. So basically you let go of the stick, the plane will auto level itself, but the throttle control is completely manual. And the auto-tune mode, as we'll see a little bit later, well, you can probably figure it out from the name, is where you throw the plane around a bit and it sort of senses the way it's moving and uses that information to automatically tune its gains to perform a little bit smoother. So that's something that you'd typically want to do in your first flight in most cases. Alright, so at that point you'd probably want to mount everything in the plane so that the rest of the process becomes a little bit easier. Now this next section here where I've set up the servos here, this is quite specific to my case. So what I've done here is I've connected the left servo to channel 1 of my flight controller. So that will be these pins here, that's channel 1, 2, and so on. Pretty simple. And my right servo is there, ESC is on channel 3. And we need to say what these outputs are going to be doing. So servo output 1 needs to know that it's moving an elevon. It's not moving a elevator or a rudder or anything like that. So servo 1 function needs to be left elevon in my case. Servo 2 function needs to be right elevon. So these uppercase names that I mentioned earlier are something that we're going to look for in that full parameters list. So let's go there and we'll go back to here and servo 1 function. Right, so servo 1 function. Now you can see I've already set this to 77, and if you look in this list here, well, I can't quite put my, there it is, 77, elevon left. So this is what you'd want for the left wing of your flying wing, and I think 78 would be servo 2 function, wasn't it? Now this next little bit here is possibly specific to my case. You might find that one of the servos needs to be reversed. In my case it was servo 2, and this little bit of information may not be useful to everybody out there, because I also on my flying wing on the FX79 I moved my servos from the bottom of the wing to the top of the wing, so you might find that it's actually servo 1 that needs to be reversed. I'm not exactly sure here, so just don't worry too much about that, but you're probably going to find that one of the servos needs to be reversed. And so that would be servo 2 reversed. Just do the same thing, search in that huge list for this value and then change it to 1. And okay, so servo 1 trim and servo 2 trim are quite handy. So in your transmitter settings you want to have your transmitter outputting dead center for everything. So if we go back into here and look at the radio calibration, notice I have pitch at 1500, roll at 1500. So this is it going to move? Oh boy, it's really slow. Yeah. So when your sticker's not doing anything, this is the value that you want to see. So you would trim your radio or set up your radio to make sure that this is the instructions that your radio is going to send to the flight controller. And then to make sure that your elevons are trimmed in the right position, usually for a flying wing you want them to be slightly upwards so that the wing as a whole has a little bit of reflex. Then you could do that here using this, like that. So, oh, I haven't changed it by the looks of it. Huh, I thought I changed this. Oh, anyway, So you could change this value there, and you should see your elevons moving a little bit when you click write params to make that setting. Alright, what else have we got? Alright, so set the plane level, put it on the ground and make sure it's level, and basically you want to put it in the attitude that you want it to be when you let the stick go and it tries to do auto level. So put it in that position and then go to do the calibrate level part of the Accel calibration page, which was the first part we started with on here. So there's this one here that's calibrate level, so you would set the plane level, click that button. Alright, calibrate compasses. For this you really want to have everything mounted in the plane. Like I said, the two compasses have to be pointing the right way relative to each other. So that is here, compass. There's a couple of ways you can do that. I would recommend this one here, which you ideally go outside so that you're not near your refrigerator or your computer or steel desks or anything like that inside, and then click the start button, and then you'll see these bars here gradually filling up with green as you go. Should be two of them, mag 1 and mag 2. You can see I've done my calibrations there in green. Everything's looking good. Not going to do it now obviously, but you need to turn around 360 degrees nice and slow, turn the plane upside down, do it again, and it really seems to work much better if you also then roll the plane on its side 90 degrees and turn round fully, and then left, and then also point the nose down and up, so you're letting the compass see all of those directions. And just do that for a while, and then after a while it should beep and you're done basically. So that's compass calibration. Calibrate ESC, that's here. Now basically just follow this steps there. It's quite detailed about what you need to do. I don't think I need to comment too much about that. Alright, so calibrate ESC, we just did that. So I think at this point we've covered all of the what they call mandatory hardware in this section here. Oh, Failsafe. Let me just show you what the default settings for Failsafe do. I've never actually touched this, but it's right out of the box. It's exactly how I want it to function. So yeah, I can't profess to know anything about this page. But let's just look at the flight data page here, and notice that I am in manual flight mode, and I'll turn my radio off, and you'll see it goes into circle mode just briefly, and then after a few seconds it will go to return to launch mode. So this is exactly what I want it to do. So when I saw that it was doing what I wanted it to do, I never bothered to figure out much about more detailed stuff that I could do. Interestingly note though, turn my radio back on, I'm still in return to launch mode, and I will stay in return to launch mode until I flip that switch to another mode and back again. So just keep that in mind. If you do have a failsafe and you want to take control again, you'll have to flip the switch to get control back. Alright, so we do have one other hardware feature that we can set up, and that is the battery monitor, because we are using a power module that will provide us with the voltage and current sensing abilities. So in the battery monitor page, make these settings there. I'll just show you that because it's easier to explain while we're looking at it. So it's under optional hardware, battery monitor, and there seems to be a variety of configurations that will work kind of, but I've found that the best combination with this radiolink mini-pix seems to be monitor set to voltage and current, sensor set to other, and then APM version set to the Cube or Pixhawk. And I also found with both of the mini-pix flight controllers that I had that the resistor that was in them was pretty much the same, so I was able to just use the same settings here. So what I would suggest you do is in this voltage divider section here, set 11.35 and then amperes per volt 15.2. That worked fairly well. Although, as I mentioned earlier, this particular flight controller, the current does not seem to be giving me any values, so I'm guessing that is a hardware fault or something wrong with that power module. But provided that yours is not having any faults, you should see a value in here for current, just the same as you do under this calced one, that is, number 5, just the same as you do here for battery voltage calced there. It's in grey because this is actually a... Actually, why is this one not in grey? Shouldn't that be in grey too? anyway, I think it's in grey because that's not something that you enter, that's something that is calculated, and you can see it's sort of changing there a little bit as the battery discharges. But in any case, when that's done, on the flight data page you should be able to see the battery voltage there. By the way, you can double click these to change them, as it just showed you, so you can select from a huge array of numbers to show there, so you don't always have to see these 6 particular numbers. Anyway, moving right along, if you have an SD card, you can insert that into the flight controller to log data while it's flying, so you can use that as a kind of a black box to maybe figure out what happened if something went wrong. And it's also quite useful if you're taking photographs and you want to match up the time of the photograph, so that is the clock on the camera, with the clock on the plane. You can use that to figure out at what location each photo was taken. So if you have an SD card and you insert that, the step here is not going to be relevant. But if you don't have an SD card, or you don't want to use one with this, you can make a change to this arming check value to remove this logging available. So this arming check, let's have a look at that. Arming, this one here, arming check. So this is a bit flag, so that means it's a combination of these numbers here. You see these numbers increase in binary fashion, so it's 1, 2, 4, 8, 16, 32 and so on. And one of them here, logging available, 1024, if this bit is set, oh, here's the explanation, bit mask of checks. These are all the checks that it will go through when you try and arm the plane, and if any one of these fails, it will not let you arm. So this 6654 value I got by adding up everything other than logging available. So if you wanted to, for example, see this one here, hardware safety switch, that is the button there that you would use. Where is it? This button thing there. So if you don't want to use that, and you just find this to be a pain in the ass that you have to push this button every time before you want to arm the plane to fly it, you could tell Mission Planner here that you add up all these numbers except for 2048, and then whatever result you get there, put that in there, and that will just ignore the hardware switch when you're trying to arm if you want to. So at that point you should be able to arm. There are other problems, of course, GPS configuration, GPS lock and so on, that will prevent you from arming. So what you'll find is if you are indoors and the GPS doesn't have quite enough of a fix, as is the case right now with my plane being inside, it'll say no fix like that, and if I try and arm now, it'll probably say, actually let's see what it says. So you hold the throttle down and to the right for 5 seconds, bad GPS health. Well, I guess that's the answer then, isn't it? Bad GPS health. This just means that it needs to be outside with a better view of the sky so that it can figure out where it is and get a GPS fix before it tries to arm. But if this one was gone, then I think it would say something about hardware safety needs to be disabled or something like that. And if I had not disabled the one about SD card, it would say in here logging invalid or something like that, something to that effect. So you can expect to see a message in here telling you why it could not arm. Okay, so that should be all the setup that we need to do in Mission Planner. Next thing on my list here is set trims to neutral. I think I already mentioned that already. And I adjust linkages to suit. Actually, that I think is why I did not have any customizations in my servo trim values. So maybe forget about these servo trim values and adjust your linkages physically with your servo horn and the length of your linkages, if you can, was a better way to do it, I guess. And then check the directions of the elevons. So in manual mode you can do that, but you also need to do it in fly-by-wire A mode as well, because manual mode just will move the elevons one way or the other, and it has no relation to which way the plane is tilting. But this fly-by-wire A mode, if you flip into that mode, you should see the elevons moving around when you tip the plane to the left and right and forward and back and so on. And just make sure that the elevons are responding in the way that will keep the plane level. Very important. That was my biggest problem when I did my maiden flight with my first plane that I set this up on. I might just also add compass direction is correct. So that's just what you see on that direction there. Check that that is actually the direction that the plane is facing in the world. A couple of optional things that you might also like to do is change the return to launch altitude and the loiter radius. And I forget what the defaults were for these, but I have a few trees around my area which are about 40-50 meters tall or so, and I just wanted to make sure that I was going to easily clear everything in my vicinity quite comfortably, so I changed it to 80 meters or 8,000 centimeters. And the loiter radius, I think, was also quite a bit smaller than 100 meters, which is okay for a smaller plane, I think, but for the size of plane that I was setting this up for, it needs to have a bit more of a wider loiter radius, because if it's trying to turn in a tight circle, it has to lean over quite a bit, and it loses lift the more it leans over, and so it needs more throttle to keep itself at the same altitude. So I just felt that 100 meters was a bit more comfortable for it to handle. Okay, so that's all the settings that you should need to make before going flying, and there's nothing else in this file, by the way. Well, there is this bit here, which I think I will mention just a little bit about, even though it's not applicable to too many people, I think, because I might get questions about it in the comments if I don't say anything. But this is very useful when you're doing aerial mapping. Okay, I have everything set up in the plane now. Should be ready for the maiden flight. We have some GPS signal. My radio is off, so obviously nothing's happening here. If I turn the radio on, we get that little chime. We still can't actually twiddle any of the elevons until we disable this, or hold this down for a little bit. It should go solid red. And now I can move these, and what's interesting is, because I had the radio off, see how it's moving there? It's actually in return to launch mode. So what I've discovered is that to get it out of return to launch mode and into the modes that you have on your switches, you need to flip the switch. So I'll go like that. That should put me in manual mode now. So yeah, something to notice. And I've set up the trims so that in my radio I have completely dead center on all of these trims here, and then I adjusted the linkages here so that I have both of the elevons just slightly above like that, because I've noticed that this plane needs to have them a little bit up. So then just check all the directions, like that is okay. So this is in manual mode, and put it into fly-by-wire A, and then check by picking this up and tilting it that the elevons are going to go the correct direction again. So when I tip it up, when I pitch it down, they should come up, and vice versa. And when I tip it that way, the higher wing elevon should come up, lower wing elevon should go down. It's not going down much, is it? That is correct though. Oh, it doesn't change much, eh? I think it's alright though. Okay, so those directions being correct is very important, because that's the way it's going to try and correct itself when you switch into that mode. So I guess you'll notice that you can't do any throttle. If you want to throttle, you'll have to arm it, so that's down and right for 5 seconds. And you hear that tone, and now you should be able to use the throttle. Okay, and then to disarm it, to be honest, I'm actually not sure how to disarm it. It doesn't seem to do anything if you do that. On Arducopter it does disarm if you do that, but for some reason this one doesn't. So usually to disarm it I just go over to the ground station and disarm it on the laptop. Answers in the comments if you know the proper way to do that, because obviously that is not ideal the way I'm doing it. So I think we are ready to take it for a fly. Okay, check that the prop's going to spin. Woo, yeah. Wow. So I'll just turn it into the wind, get it a little bit higher, and then I'll switch into fly-by-wire A mode and see what it does. Okay, here. And it's, yeah,
Yeah, it seems to be turning to the left a bit, doesn't it? Oh no, that's alright, it's straight now. So I'll turn to the left myself now, pitch back a little bit, and yeah, that's pretty good. Alright, I'm going to let the stick go here, it should straighten up. It's very slow to straighten up, but it did straighten up. So this is hands off again. It's turning to the left, isn't it? But alright, let's turn to the right this time. So this is full right stick, and let go. Straightens up, that's good. Okay, so accelerometer, gyro, controlled flight seems to be working fairly well. Alright, so here I'm going to switch into autotune, and then the idea with this is you just slam the sticks side to side, which I'm doing, but it's responding very slowly. Alright, full stick right, full stick left, full stick right, full stick left. So I'm just sort of waiting for it to get to the fully banked position, and then I just put the stick right back to the other side. I think that's how you're supposed to do this. And with this plane, it takes quite a while to bank over, so I'm going to turn around here and go full left. Ah, it's getting faster. Full right, full left, and then you do it for vertical as well, of course. I'm just doing it for left and right at the moment. Pitch forwards, pitch back, pitch forwards, pitch back, and so on. So I'll spare you the monotony of this, and I'll just come back when I've done this for about 10 or 15 minutes. Okay, I got bored of that now, so back in manual mode, and I'm going to come and land.
Well, I think I'm going to stop this video here. It's gotten long enough already, and I think this should cover the basics of getting started, enough to the point where somebody who's not familiar with Arduplane and Mission Planner could feel a little bit more comfortable with getting their feet wet and trying one of these systems. So that's the end of this video, and thanks for watching.